This is math analysis, and we are going to start working on some calculus things, including derivatives. This is the first principles of derivatives math-based assignment. This is going to be question number 1. We're going to go through a couple of these. It says, consider the function f of x equals 4x plus 3. Find f of x plus h. I'm going to plug in x plus h into the function. So I'm going to write 4 times the quantity x plus h plus 3, and then I'm just going to multiply that out. Four x plus 4h plus 3. And then find f of x plus h minus f of x. So now I'm just going to subtract 4x plus 3. And notice that we have a quantity here. So we have to use parentheses. And that's going to distribute the minus. It's going to be 4x plus 4h plus 3 minus 4x minus 3. And what should happen is you get some cancellations here. This should be 4x minus 4x, and then plus 3 minus 3. Let's hope that 4h would be our answer there. Okay, and then finally find f of x plus h minus f of x all divided by h. Now I'm going to take that 4h, and I'm going to write equals 4h divided by h. Those h's will cancel, and I'm just left with 4. Here's the important concept that we have not yet discussed. A derivative in calculus, we notate it as f prime of x. There's an apostrophe there. And the definition of a limit is given by, the definition of this derivative is given by the limit as h approaches 0 of some function f of x plus h minus f of x divided by h. We have seen this before, and this is called the difference quotient. What the difference quotient is in fact a very small change in the function by some arbitrary number h. So when that h value gets from 0.01 to 0.001 to 0.0001 and then closer and closer to 0, what does the function look like? That's why it is called the derivative. It's a derivative function. So if we wanted to take this one step further, we could say that in this problem, if the function is 4x plus 3, the derivative is the function f prime of x, which is actually just a straight line, which is 4. The other thing that's really important here is if you notice that 4 is actually the slope of the line. So derivatives, limits, and difference quotients have a very, very close application and are related to the slope of a function. But for now, we're just going to enter our answer of 4. So there's a lot of algebra here, and you have to do that for a lot of these problems. Let's try something like question 8. This is a fraction problem now, so just go through your algebra. F of x plus h should be 1 over 3 times the quantity x, 1 over 3 times the quantity x plus h. and then subtract. So now we're going to have 1 over 3 quantity x plus h minus 1 over 3x. Alright, so now we have to still do some work here. What we have to do is make a common denominator. So now, the common denominator, we're going to multiply the left equation, or the left expression, by 3x. So this is going to be three x over 3x times 3 times x plus h minus 3 times x plus h over 3x times 3 times x plus h. Now I actually didn't multiply by the least common denominator because there's a 3 in everything there. So let's see if we can write something like x over 3x x plus h minus x plus h over 3x x plus h. Okay. All right. Still not finished, so let's just keep working. And we're going to now combine these. So this has to be x minus h over 3x times x plus h. So these will cancel. Let's write negative h over 3x times x plus h. Okay, so there we are. Now we're going to divide that whole thing by h. And now how does this simplify? Well, this is the same as multiplying by 1 over h. So times 1 over h. And those h's are going to cancel. And now we're left with negative 1 over 3x times x plus h. I'm going to take it one step further. And we could say, what is the limit as h approaches 0? Well, as this thing goes to 0, then the whole function should become negative 1 over 3x squared. So that would in fact be a derivative. But for now, we just want to plug in the function f of x plus h minus f of x divided by h. So let's write negative 1 over 3x times x plus h. Make your x a little bit scripted. Okay, and then that question is done. Let's jump to another hard one. How about question 12? So now that we've talked about the actual derivative from the limit definition, so again, recall that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now we'll take you through the steps here. Find x plus h in expanded form. So x plus h squared means we should expand that to x squared plus 2xh plus h squared. You can see that limits and calculus involves a lot of algebra. Now minus f of x. So up here, this is going to be minus x squared. And look, you will generally always have some sort of subtraction. So 2xh plus h. Miswriting things. 2xh plus h squared. Okay, now let's divide this by h. So 2xh plus h squared divided by h. Keep in mind that we cannot evaluate the limit as h approaches 0 here because you would get a 0 on bottom. So that's why we need some sort of limit analysis. And our analysis is actually pretty straightforward here because we can cancel out an h here, and one of them there. So this should become 2x plus h. Hence, find f prime of x by evaluating the limit as h approaches 0 of 2x plus h. Well, if h approaches 0, then this thing will end up going away, and we should just have 2x. So the derivative function, which is also, by the way, going to represent an instantaneous slope for the function x squared, should be 2x. There you have it, an introduction to derivatives, and please complete the rest of this math-based assignment in order to earn extra credit. And have a nice day.